Assalamu alaikum. We're going to start our chapter 4, Turning Effective Forces, and we're going to look at all the details of this chapter. Whatever the content that is required in this chapter will be discussed in this video. So, firstly, we have to look at the main keyword, that is movement. And what is meant by movement? Movement is basically the turning effect of force about a fixed point. That's a definition you have to learn and memorize and write in exams. But exactly what is movement? If I give you an example, for example, you every day you open a door at your house, right? This is a door. It's an open door right now. और यहाँ पर अगर आपको नजर आता हो, कभी आपने देखा हो ये hinges होते हैं, अच्छे होते हैं, इस तरह के नहीं होते बहुत खराब जैसे मैंने बनाए हैं। तो ये है हमारे hinges on a door। जो ये होते हैं ये एक फिक्स पॉइंट होता है जिसको हम लोग फिक्स पॉइंट को क्या कहते हैं? पिवट। तो हम क्या कहेंगे? ये hinges डोर के एक पिवट है जिसके थ्रू ये डोर आगे और पीछे मूव कर रहा होता है। तो जो इसकी मूवमेंट है वो इस पोजीशन के ऊपर है। फॉर एग्जांपल एक बहुत ही ऐसी एग्जांपल जो कि आपको कभी भी नहीं मिलेगी कहीं और, दैट इज योर आर्म, राइट? ओके, दैट्स सपोज टू बी योर आर्म। तो दिस पॉइंट, ये जो आपका एल्बो है, आप अपने हाथ को आगे भी लेकर जा सकते हो, पीछे भी लेकर जा सकते हो। सो दैट्स व्हाई दिस इज योर हैंड। जस्ट बाय द वे, अगर आपको पता ना चला मेरी इतनी प्यारी राइट ड्राइंग से, तो ये हैंड आगे और पीछे जा रहा है जिसकी वजह से ये एल्बो जो है ये एज अ क्या कर रही है? एक्ट एज अ पिवट एक्ट कर रही है। तो एक फिक्स पॉइंट पे फोर्स जब टर्न होती है तो उसका क्या रिएक्शन होता है, क्या वो फेस करती है, क्या कुछ होता है, उसके बारे में उस स्टडी को हम क्या कहेंगे? मूवमेंट। तो उस पॉइंट को जहां पर फोर्स टर्न हो रही है एट अ फिक्स पॉइंट, उस इफेक्ट को हम मूवमेंट कहते हैं। For exam purposes, you can either write this definition as it is, or you can also write product of force into perpendicular distance. Force and perpendicular distance, the product of force and perpendicular distance is called moment. ये moment का formula B है, right? Which is F into perpendicular distance, F into D. F का unit होता है force है, force का unit होता है Newton, distance is measured in meters. So NM और SI यूनिट जो मूवमेंट का है दैट इज NM। क्वेश्चंस में अक्सर NCM और वैरायटी होती है आंसर्स की, बट ट्राई टू मेक श्योर कि आप अपने आंसर जो है वो SI यूनिट के अंदर ही दे रहे हो। तो अगर सिंपली मैं कहूँ कि मोमेंट और टर्निंग इफेक्ट में क्या फ़र्क है, तो जितना मोमेंट ज़्यादा होगा उतना टर्निंग इफेक्ट ज़्यादा होगा। एंड आई विल एक्सप्लेन दिस रिलेशन अ लिटिल बिट मोर इन नाउ। Now let's talk about the factors that affect movement. Movement is dash proportional to the force. We just looked at the formula of movement, that is m is equal to F into D. So what about force? If we increase the force, there will be more movement. So we can say that movement is directly proportional to the force. And for about when we are talking about the perpendicular distance, when we increase our distance, our perpendicular distance, remember, the greater the perpendicular distance is, the greater the momentum will be. Oh, sorry, not momentum, it's going to be moment. So it's directly proportional as well. Or we can even write m in directly proportional to F, m directly proportional to D, right? So as we talked about this, let me give you an example of this thing. For example, we have a, a a plus. Let's say there is something we have to put effort on. There is a lever, right? I don't know. There is any tool. So for that, if we have to, if we are going to pick it, अगर यहाँ पे हमने कोई चीज, yeah, I just got a good example. Sorry. Yes. So we have a nail here, and This is our poor hammer. That's how a hammer looks like, I believe. Yeah. So there are two ways where you can pick your hammer. You can either hold it over here or you can either hold it over here. Remember the last time you used a hammer and let me know okay, where did you actually put your hands on? Did you put on the like edge of it या फिर बिल्कुल उसके करीब जहाँ पर हमारे पास ये this heavy thing is? Obviously we pick it up over here, this place, right? So if we look at this in the case of movement, we can say कि ये हमारे पास एक pivot है, ये एक ऐसा point है जहाँ से ये इसको मारेगा और ये नीचे जाएगा नेल। तो हम लोगों ने क्या किया, हमारा डिस्टेंस जो है वो यहाँ पे ग्रेटर है, ग्रेटर डिस्टेंस ग्रेटर मूवमेंट। अगर हम यहाँ से पकड़ेंगे तो मूवमेंट ज़्यादा है, अगर हम यहाँ से पकड़ेंगे तो मूवमेंट कम है, और मूवमेंट कम होगा तो उसको मारना बहुत मुश्किल होगा। पीछे से पकड़ के वो ज़्यादा फोर्स हम दे सकते हैं, आगे से पकड़ के हमारी फोर्स बहुत कम लगेगी। सो दैट्स हाउ इट वर्क्स। ठीक है, ट्राई टू रिमेंबर दिस to make sure that your everything is working smoothly. So look at this. For instance, if you increase your perpendicular distance from the applied force a lot, that it acts at 90 degree, what happens to the moment at that time? At that time, the moment of a force will be greatest. Moment of the force will be greatest when there is a perpendicular distance between the pivot, this is a pivot, and the applied force. When there is a 90-degree angle between the object that it acts on, then the moment we will say will be the greatest at all times. Let me make a crown over it. Wait. Yes. Right? So that's how it works. Now let's do a quick exercise. Before you start watching or continue watching the video, I would recommend that you guys pause the video over here and then solve them and then get back. So let's start it on our own. Force of 10 Newton is applied at a perpendicular distance of 200 centimeters from the pivot. From the pivot is very important. What is the moment of the force in Newton meters? So let's write down the data that we have. The force is 10 Newton. The perpendicular distance is 200 centimeters. And they asked us to find the moment in Newton meter. And they gave us centimeter. So we need to convert this. We are just going to divide it by 100 and we will get 2 meters. So now we can easily apply our formula. M is equal to F into D. F is 10 and distance is 2 meters. Do not write 200, it's 2 meters. So the answer is going to be 20 Newton meters. Now the next question, the moment of a force is 50 Newton meter and it is applied a perpendicular distance of 5 meters from the pivot. Find the force. So we now know, we don't know the moment of a force. That's not a force. The moment of a force is. So moment is 50 Newton meter. Perpendicular distance, I'm just going to write D right now. So if it's 5 meters, there is no problem with units. Now we can directly apply the formula. M is equal to F into D and M हमें पता है, force हमें नहीं पता, हमें यही find करनी है और distance हमारे पास 5 है. We're just going to make F the subject and then we are going to get the answer, that is 10 newtons as the answer for this part. Now let's look at the principle of moment. The principle of moment states that the sum of anti-clockwise movement is equal to the sum of clockwise movement at equilibrium. So there are so many new terms that we are going to see. We know about sum हमें बचपन से पता है, और movement हमें पता चल गया है, equal का भी पता है, sum का भी पता है, movement का भी पता है, equilibrium का भी पता है, clockwise और anti-clockwise का भी पता है, but in movement we don't know about that. So let's look at this. पहले हम लोग डिस्कस करते हैं एंटी क्लॉकवाइज. So you must have a digital, not sorry, you must have an analog clock at your home. It must look like this. I hope you have, unless you have a house full of digital things. At least my home has, or you can just Google it. Okay. So that's how it looks like. That's a clock. Welcome to life. So what happens is कि यहाँ से हमारी जो our needle है, जो needle होती है of the clock, it goes from this to this and then this in this way. इस तरह से मूव करती है. You have never seen कि वो 12 के बाद 11 हो रहे हो, फिर 10 हो रहा हो, फिर 9 हो रहा हो, फिर 8 हो रहा हो. It's always in this motion. Whenever whatever subject or object that is going in this motion, we are going to say that it is in a clockwise motion or clockwise movement, clockwise direction basically, right? So, and if you're, for example, you have a inverse clock at your home, which is not how it's supposed to be, and it is going in other way, in other direction that is like that, then you can say you have an anti-clockwise direction. Or in short form, that's a very long term, we call it ACW, and for clockwise we call it CW. So they're saying sum of anti-clockwise movement is equal to the sum of clockwise movement at equilibrium. So ACW, sum, this is a sign or symbol of sum. Sum of clockwise and anti-clockwise is equal. तो अगर हम लोग इसको as a seesaw, that's a seesaw, इसके अंदर अगर हम लोग देखें तो हमारे पास यहाँ पर फोर्स नीचे जा रही है और यहाँ पे हमारे पास इस तरफ फोर्स जा रही है. Think of this point, this is a pivot, think of this point as the middle of the clock and think कि यहाँ पे 4 बज रहे हैं, यहाँ 5 बज रहे हैं, and then this is going to move like this. तो यहाँ पे 6 बज रहे हैं, तो किस डायरेक्शन में मूव कर रहा है? Clockwise. And if you think about this, think of this as 9 o'clock, 8 o'clock, 7 o'clock, and this is the pivot, and it is moving in this way. So this is going anti-clockwise. And we can also think of it in another way. Let me draw it. You can see I did not change the direction. ये भी इस तरह है, ये भी इस तरह है, ये भी इस तरह है और ये भी इस तरह है. तो अब इसके अंदर इंस्टेड अगर मैं इसको देखूं ये नीचे से फोर्स जा रही है, व्हाट अबाउट मैं अगर देखूं ये ऊपर फोर्स जा रही है और इसको मैं देखूं कि ये यहाँ से नीचे की बजाय इधर से भी तो ऊपर जा रही है ना फोर्स. तो इस पोजीशन में अगर देखा जाए तो दिस इज 3 o'clock, दिस इज 2 o'clock, दिस इज 1, 12, 11. सो इट इज मूविंग इन दिस मैनर. तो अगर वो इस मैनर में रोटेट कर रहा है तो इट इज स्टिल मूविंग एंटी क्लॉकवाइज. And if this is 9, this is 10, this is 11, this is 12, this is 1, 2, and so on. So this is moving in this direction. So it is again a clockwise direction. So अगर आप बेशक आप नीचे से देखो या आप ऊपर से देखो, these are going to stay anti-clockwise. And what is equilibrium now? We know about all of the terms, but not equilibrium. Equilibrium is the balanced state. We are going to look into the condition of equilibrium, but firstly let's discuss what is balance, what is equilibrium. Equilibrium is that balanced state in which our seesaw is not in any one direction, it is balanced, it is equal in both sides, and having the there is no net force here. That was the conditions. So no net force, number one condition. Number two condition is no movement. When there is a no movement or no turning effect, then we have achieved a state of equilibrium. Or in other words, or simple words, you can just call it balanced state. Now let's look at conditions of equilibrium in peace. So the first condition is sum of moments about any point is zero. That's the POM, the principle of moment. That's just my fancy way of writing it. So in this way, we are talking about the anti-clockwise direction of movement should be equal to clockwise movement. And if we look at this, wherever force we are going to put over here, जितनी भी यहाँ पर इस तरह से anti-clockwise movement चलेगी, उतनी ही यहाँ से वो क्लॉकवाइज भी चल रही है. दैट इज वाई इट इज इन अ स्टेट ऑफ balance or a neutral state. The second condition is vector sum of forces on object is zero. The vector forces of sum, basically they are telling us that upward force should be equal to downward force, or you can say there should be no net force, or it should be balanced. And anti-clockwise and clockwise already talks about, you know, going over here and going over here should be equal, right? So in this case, हमारे पास अगर ये जो नीचे है ये हमारे पास weight है for talking about the force, and the upward that's the normal force or contact force that we have studied in the previous chapter 3, I guess. That's how it works. Let's do some exercise questions. So we have this scenario and they ask us to find W2. Let's look at this. This is the pivot, this is a rod, this is the weight 1 that is over here, or pivot से weight का distance है 0.6 meters, pivot से दूसरे weight का distance है 0.9 meters, and the weight 2 we do not know about that. We have to calculate that. So we have to see the question. It is saying that it is in equilibrium. That means ACW is equal to CW. ठीक है? Sum of anti-clockwise movement is equal to the sum of clockwise movement. So in this case, सबसे पहले हम लोग इस चीज को देखते हैं कि जो weights हैं ये किस डायरेक्शन में जा रहे हैं. This weight is going over here, which is 9, 8, 7, 6. That's an anti-clockwise, and these weights are going over here, that is a clockwise direction. So now what we are going to write is यहाँ पे हम लोग ACW लिखेंगे is equal to लिखेंगे. Oh, make sure you add this. I always forget this. Okay, so write this. Now we have to write the moment का formula from anti-clockwise and moment का formula for the clockwise. So the formula is F into D should be equal to F into D. Force of anti-clockwise is 150. Distance, perpendicular distance between the pivot, that is 0 point with the pivot 0.6, and about the force we don't know, that's W2, and the distance we know 0.9 meters. Now simply we are going to multiply 150 with 0.6, and then we have to divide it by 0.9 and is equal to W2, and W2 will be 100 newtons. I just got it already done. मैंने पहले ही multiply कर लिया था, इसलिए मैं आंसर बता सकती हूँ फौरन से पहले. Oh, I forgot to write the question for this one. Okay, I'll just explain it. We have to basically find the force. The force was should be over here. That's the force. Calculate F. Let me explain you the scenario first. The scenario is that this is a very tall person. Very tall person goes to a grocery shop and somehow they got a bad trolley, और उन्होंने जो है previous जो पीछे वाले उनके टायर्स थे वो सारे खराब हो गए थे because there was so much stuff inside it, right? So this got broke and we just have these front two wheels to move this trolley. Now this person, this tall person, wants to move this, and they are asking कि इसको कितनी force upwards apply करनी पड़ेगी, because now they have to do one wheeling of a trolley. तो उसको अब उठा कर चलना पड़ेगा, तो कितनी force इसको अपने हाथों पे लगानी पड़ेगी इस tall person को. We have some values. 600 न्यूटन हमें weight बता दिया गया है, 0.5 meters, 0.9 meters, distance इतना इतना बता दिया है. We have this pivot and we always look at the distance from the pivot. तो अगर हम लोग इस वाले weight को देखें तो ये weight anti clockwise जा रहा है, clockwise जा रहा है. Firstly we have to look at this. This weight is going like this, which is a clockwise movement. That's what we know now कि हम clockwise movement कर रहे हैं. So now we have to write sum of anti-clockwise. What's happening? Sum of anti-clockwise moment should be equal to clockwise moment, and we can see कि जो अब ये वाली भी तो force है ना, upward force किस तरफ चल रही है, इस तरफ से, क्योंकि pivot ये है, pivot के according along चलेगी ना, वो इस side पे तो नहीं चल सकती, इस side पे तो pivot ही नहीं है, just pivot के side पे चलती है ये. पिवट की साइड पे यहाँ पे हमारे पास ऑपोजिट चल रहे हैं, so that's anti-clockwise moment. Now anti-clockwise moment F into D is equal to F into D. So F, ये वाली इसकी फोर्स F आ गई, और डिस्टेंस कौन सा लेंगे हम, पिवट तक का डिस्टेंस लेंगे 0.5 प्लस 0.9, तो ये सारा डिस्टेंस आएगा फॉर दिस पर्सन, फॉर दिस ह्यूमन बीइंग. So the distance is going to be 1.4, that is 0.5 plus 0.9, और फोर्स जो है हमारे पास जो क्लॉकवाइज डायरेक्शन में है दैट इज 600 न्यूटन, एंड उसके साथ जो डिस्टेंस है वो सिर्फ इतना सा है 0.5 मीटर्स. तो 0.5 से मल्टीप्लाई कर देंगे एंड F इज इक्वल टू 600 multiplied by 0.5 divided by 1.4, we will get the final value as 214.3 newtons. That's it. Now you know this exercise as well. Alright, let's jump into center of gravity. The definition for center of gravity would be the point at which the entire weight of the body appears to act on. Basically, it's the point where the entire weight is acting on. I just repeated the definition. So, center of gravity itself would be a middle of a regular object, and it is also called a point of balance. Let's look at why it is called a point of balance. Firstly, you can see that I have drawn some regular shapes, regular bodies. These are square. Oh, this was supposed to be a square, but it seems like a rectangle. Let's think of it as a square as well for this case. And what we are going to do here is, let me change the color first. Let me make it pink. Okay. So now when I'm going to do, what I'm going to do is कि मैं हर तरफ से, हर डायरेक्शन से एक लाइन पास थ्रू करूंगी कि इन द मिडल, इट शुड बी इन द मिडल. मिडल से एक यहाँ पे पास की, एक इधर से पास की, एक चलो डायगोनल पास कर दी, एक उस तरफ से भी पास कर दी, एंड द मिडल पॉइंट जिनके साथ ये सब कुछ होगा वी विल कॉल कि यहाँ पर हमारी सेंटर ऑफ ग्रेविटी एग्जिस्ट करती है, कि दिस इज द मिडल पार्ट, दिस इज द पार्ट वेयर एवरी थिंग इज एग्जिस्टिंग, एवरी जो वेट है इस बॉडी का वो यहाँ पर एग्जिस्ट करता है. एंड इफ वी सिमिलरली इफ वी टॉक अबाउट rectangle, it will be like this, and then let's make this like this, and then थोड़ा सा मेरा ये लो, I'll be exact, नहीं हुआ exact, थोड़ा सा ऊपर होना चाहिए था, but we have an estimate कि this is the center of gravity, and without even looking at this shape can we already tell कि इसका center of gravity क्या होगा. Definitely it will be there. So it's going to look like this अगर हम लोग इसको हर डायरेक्शन से करें with the correct line, it will be like this. So यहीं पे हमारा बनेगा middle. थोड़ी मेरी लाइन wobbly हो गई है, but this will be the center of gravity. And what about the circle? मेरा circle थोड़ा सा बैठा हुआ है, but I'm talking about the regular circle. Regular circle में we will have the main point in the middle. No matter how many lines we are going to make, it's still going to be in the middle. You can make 1,000 other lines, but the center of gravity is not going to change. So this point will be the center of gravity. So now let's look at the first point. Center of gravity will not change regardless of how the object is oriented. So it does not matter if our rectangle is vertical or horizontal, we will still have the center of gravity will be the same. It's still going to be at the same position where it was previously. So somewhere like this. थोड़ा सा मैंने इशू जरूर किया, पर यहाँ से भी तो नहीं किया ना गैप. So that's it. So this is going to be your center of gravity. And one important point, that center of gravity can lie outside the object. Think of this as your donut. And where do you think the center of gravity will lie? The center of gravity will definitely lie in the middle of the regular object, जो कि हमारे पास सर्कल है, उसके यहाँ पर अब सेंटर ऑफ ग्रेविटी एग्जिस्ट कर रही है. Why? Because even though there is nothing in there, it's air, it's empty, but it's still holding some weight, some space. So we will still consider this point as a center of its gravity. Similarly, there are other stuff. For example, if there is an object that has a huge mass over here, and then a little too long mass of air, and you can think कि ये वाला जो इतना सा एरिया है, you can think of it as a thermometer. Maybe इसका जो ये वाला एरिया है इतना था ना हो जितना ये हो, तो हो सकता है ये वाला पॉइंट या यहाँ पर कोई पॉइंट हो जो उसकी सेंटर ऑफ ग्रेविटी हो. ये हमें ये इरेगुलर ऑब्जेक्ट है, रेगुलर ऑब्जेक्ट नहीं है. तो इरेगुलर ऑब्जेक्ट के सेंटर ऑफ ग्रेविटी को फाइंड करने का सिमिलर वे है, बट लेट्स लुक एट इट्स एग्जांपल फर्स्ट. Now we have a irregular object and we have to find center of gravity of this. So let's take lamina for an example. This is how a lamina looks like, something like a map. So what we do is we take a stand and we hang lamina. Firstly, we make some holes in it, A, B, and C. There can be multiple. So you just hang your lamina inside this rod. ये rod है इस stand की, ठीक है, इसके अंदर आपने डाल दिया, and then you observe a plumb line that cuts lamina. So this is the plumb line. This is what we use to check if the vertical height is parallel or not. So अब हमने यहाँ पे प्लम लाइन लगा दी है, अब इसके अकॉर्डिंगली बिल्कुल प्लम लाइन हमेशा बिल्कुल स्ट्रेट जाएगी, वर्टिकली जाएगी. तो हमारे पास हम क्या करेंगे, यहाँ पर हम लोग एक लाइन ड्रॉ कर देंगे जो कि बिल्कुल उसके जो प्लम लाइन के इक्वली जा रही होगी, एंड वी विल मेक अ क्रॉस ओवर हियर. सो दैट्स व्हाट वी विल डू कि हम स्टार्ट से लेकर ए पॉइंट से लेकर उसके एंड तक एक लाइन ड्रॉ कर लेंगे, स्ट्रेट लाइन, राइट. ड्रॉ स्ट्रेट लाइन फ्रॉम होल ए टू द एंड. एंड व्हाट वी आर गोइंग टू डू नेक्स्ट इज हम लोग शिफ्ट कर देंगे लेमिना की सिचुएशन. अब हम ए की जगह बी को हैंग कर देंगे. अब इस सिचुएशन में बी हैंग हुआ है और ए और सी बाकी अलग अलग पॉइंट्स हैं. ए के हमने यहाँ पे ऐसे बनाया था, ये एक ए का बना हुआ है. अब हमने लेमिना को दोबारा से हैंग किया, और दोबारा से लेमिना को हैंग करने की वजह से यू कैन थिंक यहाँ पे एक स्टैंड है, इस तरह से एक स्टैंड है जिसके ऊपर ये पड़ा हुआ है, और फिर हम लोगों ने यहाँ प्लम लाइन भी रखी है. प्लम लाइन के थ्रू हमने बिल्कुल मिडल में एक लाइन ड्रॉ कर दिया, सही है. उसके बाद फिर हमने दोबारा से होल सी से डाला है, और होल सी से अब उसको डाला है, अब वो इधर से आ रहा है, एक इधर से लाइन बन रही है, एंड देन एक इधर से लाइन बन रही है. Now what we got here is point where all lines intersect each other is the center of gravity of lamina. This is the center of gravity of lamina. So that's how we do for any object that's irregular. We put several points across the lamina, and then we hang it, and then जो उसका center होता है, that's the center of gravity. हो सकता है कि इन जो laminas मैंने draw किए हैं, because they're not to scale and I drew them randomly with my free hand, तो इसमें थोड़ी सी प्रॉब्लम्स आ सकती हैं, बट इन एग्जाम और wherever you are doing that in real life, it will not cause a difference and you will have a straight line. Now we are on to the last topic of this chapter, that is stability. That is an ability of an object to retain its original position after being displaced slightly. For example, if you are pushing something for you're pushing a little, and the object topples or like falls, then there is no stability. But if an object comes back to its original position, then that's what we call a stability. Let's look at this jar has a huge base and then it has a little top. So if you're putting something over in this jar, and if we push it over here, a slightly push, something is going to happen? I don't think so. Nothing's gonna happen, nothing's gonna move. But if there's a fancy vase that looks like this, or it's a fancy ball that looks like this, and you accidentally pass by through it and you accidentally touch this vase, what is going to happen is this is going to fall. So you can already tell कि किसकी stability है किसकी नहीं है. This one has a stability and this one does not have a stability. That is due to the base area. The greater the base area is, the more stable it is. The less this base area is, the less stability it has. Then we talk about this. कोन, इस कोन के अंदर भी अगर हम देखें इसके बेस एरिया नीचे से ज्यादा है तो ये नहीं गिरेगा, बट अगर हम लोग उसको ऐसे रखने की कोशिश करेंगे लाइक इन्वर्टेड, it's definitely going to fall. So what we can say that base area, no sorry, so what we are going to say is कि जो stability है, the more stability we will need, the more base area should we have, right? So that's the relation we can talk about. And height of center of gravity, so we just looked at what is center of gravity. तो अगर हम लोग इस ग्लास का निकालें तो इसके सेंटर ऑफ ग्रेविटी, क्योंकि ये रेगुलर है तो इसको हमें लेमिना पे अटैच करना पड़ेगा, वो सॉरी रोड पे अटैच करना पड़ेगा। रोड पे अटैच करेंगे तो ये टूट जाएगा वैसे तो, पर इसका जो भी अगर हम लोग मेथड्स हैं यानी कि हम मुख्तलिफ तरह से अगर जहाँ पे मेन वेट लाई करता है वहां से अगर हम लोग लाइंस को एक्सटेंड करें तो दिस इज गोइंग टू बी द सेंटर ऑफ ग्रेविटी, and for this one the center of gravity is going to be above. So as you can already tell कि इसका center of gravity नीचे है, इसका ऊपर है, तो जिसका center of gravity नीचे होता है या lower होता है, that's more stable than the one जिसके center of gravity above हो। तो center of gravity अगर हम लोग lower करेंगे, and I've already written this point that stability can be improved by lowering its center of gravity and increasing its base area. जितना बेस एरिया ज़्यादा होगा उतना ही वो मज़ीद स्टेबल होगा, जितना लोअर होगा सेंटर ऑफ ग्रेविटी उतना ही वो मोर स्टेबल होगा। इन दोनों के अंदर अगर हम लोग बात करें तो यहाँ पे हमारे पास जो center of gravity है this is going to be the same, but due to the base area, less base area, it's going to be unstable. So both of them are required. For example, if we talk about a cone that looks like this, that it's just it's it's on the, इसकी एक साइड जो है वो नीचे ग्राउंड या टेबल को टच कर रही है, इन दिस केस इट इज इन अ न्यूट्रल स्टेट, it's neither unstable, it's nor stable, it's just a neutral state. And if we talk about a cylinder, if I talk about a cylinder, let's look at a cylinder like this. If we have a cube like this, it's a sorry cylinder like this, ठीक है, अगर इस तरह का cylinder है it's stable. But if we have a cylinder that has a very lower base and okay ये बहुत ही अजीब cylinder है, please don't mind my cylinder. Let's look at this. For example, this is a pencil. Pencil is also a cylinder. अगर उसकी वो cone वाली shape ना बनी हो, pencil sharp ना हो, so it looks like a cylinder. Let's look, imagine this as a pencil. So this, if we try to put it upward vertically, अगर इस तरह रखें हम लोग तो it's very unstable. एक second के अंदर pencil गिर जाएगी. But if we have pencil lying like this, definitely it's neutral. It's not even in uh, stable or unstable state, it's a neutral state. So slight displacement from equilibrium mean position depends कि हमारे पास चीजें stable है कि नहीं. अगर it returns to its original position at as its okay it wasn't uh, return भी कह सकते हो retain भी कह सकते हो, yeah both of them are fine. So slight displacement अगर हम लोग equilibrium या mean position से करते हैं और वो अपनी जगह पे वापस आ जाती है, then that means कि it's stable. But अगर it topples or it falls, if it topple over or it falls, then that means कि it is unstable. And for the neutral case, it will stay in the new position. It will be fine. जो ये होगा ये गिर जाएगा. But usually we are talking about stable and unstable. Neutral cases are very rare and they are not asked very usually. And a little tip that how we can lower the center of gravity is by adding weights lower in the lower part. For example, अगर यहाँ पर है, अगर हमने इस ऑब्जेक्ट के, let's talk about this object, इस ऑब्जेक्ट को हमने मजीद stable करना है, we have to do something. What we are going to do is we are going to make another base that looks like this. For example, we can make a base like this. You have seen an hourglass, right? Hourglass like this. Hourglass इस तरह से होते हैं, तो वो स्टेबल होते हैं क्योंकि उनके मिडिल पोर्शन बेशक उनका पतला है, बट बेस एरिया, बेस इज more. So whatever object that has a more base is more stable. That's that's it. And if someone has any questions in this chapter, they can let me know about this, and I would love to help you guys. Till then, Allah Hafiz.